Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, we're going to be dealing with scripted rules. All right, so what I have on the screen here is a new instance of HEC ResSim. I'm going to build out a reservoir network, run it with no rules, and then we're going to add some scripted rules and then look at the results. All right, so let's go ahead and start from the top. In the top left, make sure you have the watershed setup module selected, and then click File, New Watershed. Okay, give your watershed a name, and then also you can give it a description. Then you want to select the location that you want that watershed directory to be saved to. Okay, and then the units, and then finally the time zone. Click apply, and then OK, and then OK. All right, so our watershed directory has been set up. I'm going to go ahead and zoom in, and then click this stream alignment tool on the left. Hold down Control, and then make a few clicks. Let go of Control before your last click, and then give the stream a name. I'm going to call this Stream West. Okay, I'm going to sketch another stream alignment tool, stream on the east side. Just hold down Control again, and then before your last click, go ahead and let go of Control, and then Stream East. Okay. Do I want to connect the streams? Yes, I do. Yes. All right. Next, I'm going to add some computation points. So I click the computation point tool, hold down Control, and then single left click on the stream alignment. I'll call the first one CP1. Okay. Then I'm going to sketch a reservoir by selecting the reservoir tool, holding down Control, and then single left click on the stream alignment at the upstream end, and then let go of Control, and then click again at where you want the dam face to be, the downstream end, and then give the reservoir name. I'll call this Reservoir West. And then let's do a computation point here, CP4. I'm going to add another computation point at the upstream end of the east branch. I'll call that CP5. And then another reservoir on the east branch. I'll call that Reservoir East. And then how about a computation point downstream of that, but upstream of the confluence? 6, 7, that'd be 8. Maybe too many of these, but let's do one at the junction and then one downstream of the junction. CP9. At this point, I have to select this drop down that says I want it to be at the junction as opposed to only on one of the streams or neither. So I'll click OK, and then one at the very bottom. Okay, looks good. I'm going to go Watershed Configuration Editor, Configuration, New. I only have one configuration, so I'm just going to go Config 1, and then 1 hour is fine, apply, and OK. All right, so I'm going to go ahead and go File, Save Watershed. That's all we need to do here in the Watershed Setup module. Next, I'll go to the Reservoir Network module and create a network that was based on that configuration. So we got our junctions and our reservoirs popped into place. I'll just call this Network 1, and then make sure to select configuration that we just saved, and then click New. All right, next I need to connect all these junction points together. So I'll click the reach tool on the left here. Let me zoom in a little bit. Okay, yeah, select the reach tool and then hold down Control and single left click on the upstream junction, let go of Control, single left click on the next adjacent downstream junction. You can give that reach a name. I'm just going to accept the default name that it gives me here and click OK. And then I'm going to repeat that process for the other reaches. Network, save, and we're good there. All right, I'm going to define inflows for the upstream most junction on the west stream and the right stream, CP1 and CP5. So I'll select my junction tool, or you can just select the pointer tool. That would work too. Right click on the junction, edit junction properties. You can also just come up to here and go edit and then junctions, and then select which junction you want to edit. Doesn't matter. Okay, so we want to add a local inflow to CP1 and CP5. So I have CP1 selected here. I'm going to select the local flow tab, and then on the very first row, go ahead and say local inflow, at CP1, factor of 1, and then apply, and then select CP5 here from the dropdown. Local inflow at CP5, factor of 1, and apply. Apply saves it without closing. OK will save it and close the dialog box. All right, so let's go ahead and actually define those inflows now. Right now, all we did just now was to tell the alternative editor that it should be expecting a inflow, but we need to create that time series, and I like doing everything here from scratch so all exercises can be followed. So to do that, go ahead and go Tools, HEC DSS View. You can also open up HEC DSS View as a separate application if you like. But let's do this. Let's go File, New. We're going to create a DSS file. I'll call it Time Series. Data. Okay. So that file has been created. Next, I'm going to go up to Data Entry, Manual Time Series. This exercise is going to be for the month of May 2024. So I'm going to just type in some path name parts here. It's going to create the path name for me. Project, location, flow. And then I'll call this Inflow West. And then for the parts, the start date will be the 1st of May. And this is hourly, so I'll set it to the first hour. Units will be CFS because I selected English units when I set up my watershed. And then right here, I'm going to actually paste in the data that I have saved on my clipboard. Okay, so I copied data onto my clipboard from Excel. And what you're seeing here is hourly flow rates, which start at 3,000 and then ramp up. So I will show you what that looks like in just a moment. If I select that record, here is the time series in green. So it starts at 3,000, then it kind of goes up and down to 5,000 and then back to 3,000. And this represents CFS. We will assign this to our west branch in the reservoir network. Next, I'm going to right click, and it's going to be a little quicker to just duplicate that record and then change west to east. And OK. So here's our east record here. Of course, it's just duplicated, but what I want to do is basically create a similar record, but I don't want it to be exactly the same. So I'm just going to delay start and create like a time offset by a certain number of hours. Edit. Here are the values. I'm just going to go ahead and edit these values. Okay, so I'm pasting in new values. I'm going to save, no. And then I'm going to display both of these time series together so you can see that it's the similar data, but it's offset. So red was the original for the west, and then the green time series here is going to be used for the east. Both have a baseline starting inflow of 3,000 CFS and ramp up to 5,000 CFS. Okay, so just remember we have this data that we're going to assign to an alternative in just a little bit later in the exercise. So I'm going to close these windows and then return to my main reservoir network module here. And it's time to add some data to the reservoirs itself. So I'll click the reservoir tool and then right click on edit reservoir properties. It doesn't matter which one you select because you can select the other reservoir in this drop down box here. So let's start with the reservoir pool. Let's first edit west and then east, even though alphabetically east comes first. I like working left to right. All right, so here's the pool. This is where I enter the pool geometry. Now I'm going to paste in data. You can type it in, but I just had data saved on my clipboard. I copied onto my clipboard from Excel. Here's the data. I'm going to use a top of dam elevation of 1,500 feet. So I'm going to click apply here, go over to the dam, and then say 1,500 feet. And I'll just make up a number here for the length and then apply. Then I'm going to go over to the east reservoir and basically make the exact same edits. So click pool, paste in that reservoir geometry, apply, and then the top of dam elevation is 1,500 again, and apply. All right, next I'm going to create a controlled outlet on both these reservoirs on the dam face. So right click on dam, add controlled outlet, and then paste in my data for the controlled outlet, which shows the max capacity based on the water surface elevation. And I'm just going to leave it at 1 gate here. So that's good for the west reservoir. Apply. And then over at the east reservoir, right click, add controlled outlet, and then paste that data in there again. Okay. All right, so next over at the Operations tab, let me select the West Reservoir again. Now I'll create operation set and zones and top of zone elevations, and then we'll get on to alternatives and simulation. So we're almost done with the reservoir here. Hang with me. Operations, new. I'm going to call this operations set west. Okay. I'll say the top of the flood control is 1500. Apply. Top of the conservation zone will be 1480. Apply. And top of inactive will be 1350. And apply. Okay, that was for the west reservoir. For the east reservoir, same thing. Let's go operations, new operation set, OS East. Okay. Top of the flood control zone, 1500. Top of the conservation zone, 1480. And then top of the inactive zone, be 1350. That 1480 water surface elevation at the top of the conservation zone, that will serve as the guide curve elevation in ResSim because the conservation zone is selected as the guide curve. All right, so that's good for editing the reservoir. This it has no rules to it. We'll come back and add rule and do all that in just a little bit. So that's where the scripting comes in. That's the exciting stuff. But let's just go ahead and run a simulation by creating an alternative and then come back. Okay, here. Let me go network, save. Now alternative, edit. We'll go ahead and go alternative new. We'll just be very generic and say alt 1. Okay, it's based on network 1. We'll use a 1-hour time series. And then for the operation set, we'll go ahead and select the operation set we created. The look back period is going to be sort of the warm up period for the simulation. Before the simulation starts, it still starts with a look back, sort of a warm up. The elevation, all we'll say is 1480 for both reservoirs. And then the flow rate, I will start at a constant 3000 CFS, which is the base flow elevation in those two inflow time series data sets we created. And then the last step is to assign those data sets. So CP1, this is the west reservoir, sorry, the west stream here, and west reservoir. I'm going to, select that record and then click select DSS path. Then I'm going to navigate to that time series data.dss file and then select west. And then when I click this set path name, the data populates back here. And then I'll select the other record. Now it's looking for the east time series data set. There it is. And then click set path name. That's populated. So I can close that. We'll save our alternative and we're good there. All right, let me just save the network to be safe and then go over to the simulation module here in the module dropdown, select that. And then we're going to go simulation new. We call this simulation 1. And then we're using the month of May 2024. So we're going to go May. Actually, let's start this simulation on May 2nd on the first hour. May 1st is when the look back period begins. So that's a 1. The end date will be the end of the month at the final hour of the month. And then I'll select our alternative, Alt 1, and click OK. All right, so our network is now on the screen, and we see in the simulation tree on the right here, we can see our simulation and our alternatives. All right, well, I'm going to go ahead and click Compute Alt 1. You can do that, or you can just right-click on the alternative and click Compute, same thing. The alternative runs, and now we have our results to take a look at. I can right click on the plot and see that it's pretty much as expected. The top plot shows a constant water surface elevation at 1480. That's our guide curve elevation. And then the bottom plot shows the flow through the reservoir. There's the inflow, which is in black here. And then the release is the exact same thing, and that's in green here, which makes sense because we have a constant elevation in the reservoir. We could do the same thing for the east reservoir. It's basically the same thing with where the inflow matches the outflow. Okay, let's go ahead and add some release rules and some scripts. Go ahead and create a trial based on that alternative. So alternative will be our base case with no rules at all. And then I'm going to create a trial, which will just be called script rules. Okay. And then right click on that trial, edit run. Now I'll click reservoirs. Now the operations, only go West Reservoir first, and then Operations tab. And what I want to do is right click on the zone, add a new rule, call this script. It will be for the controlled outlet, and then this will be a script type rule. Okay, the rule gets created over here in the zone rule tree, and I'm going to right click, add rule to all zones. Okay, that's good. Apply. Now I'm going to make the screen a little bigger. Okay, I've got the screen bigger, and what we have here is the boilerplate code that it starts us off with. This is the init rule script method that runs at the one time before the actual regulated compute, and then also the run rule script that runs once a time step. All right, so this is I'm going to comment out the maximum of 1000 CFS rule that it gives us. We don't want that to happen. We're going to do something different here. What I'm going to do actually at the top of the init rule script is paste in just a print line so we can keep track of where we start outputting our print statements to the console log, which I've found helpful for debugging and just kind of getting my head around what the data is and what I'm looking at. Next, I'm going to go down to run rule script, and let's start by adding our inflow data here. It says add your code here. First, I want to get the inflow total that we've had up to the current time step. So I'm going to go inflow total, and then inflow west time series equals. So I will go up to my time series data module model variables reservoirs. I'm going to do west first. Then I'm going to find the inflow, which is cool in. Put my cursor where I want that code to go, double click, and it gives me just what I want there. I'm going to do the same thing for east. So I'll go inflow east time series, and then navigate to my reservoir east. And then this is going to be full flow in. Okay. Next, I'm going to get the cumulative total. So inflow total west equals. Now I need to go down to the API tree where I have the time series data. And I believe there's a function for get cumulative total. So I will double click that. And then what I need to do here is identify the time series, the current run time step, and so I'll copy that and then paste it here. And then this integer here, I believe represents the number of steps back from current. Let me double check. So I'll click on time series and then F1. It gives me the Java docs documentation. And I want to double check what get cumulative total method does. So let me just find that here. Right, so it says get cumulative total. First it wants the runtime step and then the end period where it gets the cumulative total starting at that runtime step, going back the number of period steps. Okay, so let me just push that off to the side here. What it's looking for this second parameter is the number of steps. So I need to write step, and then I need to define step up above to say which step I'm actually on. Step, and then I think is there a get step time series? Oh, hold on. There's a runtime step right here. Get step. Okay, pretty sure this is it. So I will double click. Also, if I just do a single click, I believe it highlights the variable in all the spots. That's good. All right, we need to do the same thing for east. So I'll do inflow total east, and this is the cumulative total. So I can just actually, oh, hold on. I need to also give it the time series. And then I'll do the same thing for east, but it will be the east time series I'm using. Okay, I think that looks good. Let's go ahead and output that data to the console just so we can test out our print statements and kind of get started one step at a time. Okay, so what I've done is I've added some print statements here to show the total inflow west and east, and also print out the step and the current date time. So I can see for each run, for each hour, what the date time is, and then what is that cumulative flow. All right, so let's go ahead and just give that a test. It's going to be the same simulation, the same releases and everything, but what will happen is this rule will run in our reservoir west, and we'll see the console results. We'll see that this data that we're looking at. So I'm going to go ahead and click apply. That will save. I'm just going to pull this to the side here. One thing I'm going to do is actually open the console log first. I'm going to go tools, console log. I'm going to scroll down to the bottom and then just position this over here to the side. And then, yeah, scroll to the bottom. So whatever new happens, I could just scroll down and see the new output. And we'll click compute. Okay. So it computes the same thing as before. Click close. And now over here on the console log, I can scroll down a little bit. Here's my text to say where I'm starting. And then we have our steps. It starts at step 25 because we are starting one day into the simulation. So instead of step 1 through 24, representing the first day of May, this is 25. So it starts the first hour, but on the second day of May. And we see what we expect to. First, there's a cumulative of 75,000 because it's 3,000 every hour. So it'll fill up, it'll be 72,000 in the first 24 hours, and then 75,000, 78,000, 81,000, and so on as the hours click by. Okay, so I'm going to bring the code back up into place here. This is our reservoir rule. Again, it's only for the west reservoirs. All right, so let's go back to where we were. Let me make some more space here. To save some time on typing, I'm just going to paste in what I have prepared. So what I'm doing here in this next code block is I'm getting the release total and the release previous. So I'm getting the time series for both east and west reservoirs. And then with that time series, I'm getting the release to date using the same get cumulative total function and the same current runtime step and step parameter. And then also the release previous from both the west and the east reservoirs. I'm going to add those printouts down here. So that's for the east, and then this is for the west, and then I'll click apply. I can just kind of keep my eye on these numbers in case something doesn't look quite right in the simulation. I can go back and track it and debug it using my console log output. Okay, let me scroll down and give myself some more space. I got more code to type in here, and there it is. So I just pasted in all of this right here. We've seen this in a previous exercise, but I'll talk you through it. I'm getting the guide curve elevation for both the west reservoir and the east reservoir. And this is at the current value. So this is at the beginning of the time step. And what you can do to get this is just type in your variable name for get elevation west time series equals, and then you'd go up to here, the time series model variable, the reservoir, and then like for west, you'd select west and then double click on this pool elevation. Doing so would get me this string right here. It gets me the time series, and then I can get the current value, which would be 1480. I made the note, but it may not be a constant water surface elevation or guide curve elevation. So that's how you do that. The next block of code down, I'm getting the previous water surface elevation. And then after that, I'm computing the difference and then taking the absolute value so that I know what is that positive value of the vertical difference between the water surface elevation and the guide curve, or the water surface elevation and the guide curve, whatever. I just want to know what that difference is because I'm going to use that in my release rule. Speaking of which, this is my release rule right here. I'm pasting in. So I have a release west and a release east. This is the west reservoir. So I'm going to set the release equal to release west. And then this release is going to be assigned down here to the specific release I want. I'll copy, paste, type in a release, I guess. And then this is a specific release rule, so I'll copy the specific type from the options here. And then I'll paste that in as the first parameter. This release right here, I kind of didn't talk about it. It is going to be the release west because I'm in the release west reservoir. This previously release west, we have that up here because we got the previous value. And then the previous release east would be its counterpart just right here. And then this adjustment value is going to adjust based on the cumulative inflow, the cumulative release, as well as the water surface guide curve at delta. So that's what I'm doing here. Okay, this value here is the release adjustment west, and it's based on the total inflow, the total release. It's taking that difference. So it'll increase It'll be a positive number if the inflow is greater than the total release, and negative if there's more release than inflow. And then this multiplier I just created, just kind of playing around with numbers, trying something new with the script, because that's the flexibility that writing scripted release rules allows us. This multiplier is basically that delta divided by 1,000. I tried it with a few other numbers, and I felt like if I didn't divide by 1,000, the multiplier would be too high. All right, so that gets me the adjusted release, and that's added to the previous release, and that will be updated for each time step of the simulation. Of course, this is only for the West Reservoir. So I'm going to copy this entire code into a scripted release rule for the East Reservoir as well. And then I'm just going to have to change this variable from release East to release West. There's probably a better way to do this and to keep my code in a more centralized location like a class or something, but I'm not focusing on that right now. I'm focusing on just building a scripted release rule and kind of playing around with the simulation itself. All right, so I'm going to go ahead and click apply. And then, okay, when I click apply, it saves it, but it also brings the screen to the very top. It scrolls me to the top. You just kind of have to get used to, I suppose. And then, yeah, I could print out the data. I'm not actually going to use this unless there's a problem. So I'm going to just do a multi-line comment for now. But I kind of wanted to show you that this was how it helped me kind of figure out what was working and what wasn't. I'm going to go ahead and Control A to select all, Control C to copy. And then we're going to select the reservoir east. I'm going to say new rule. It's going to be called script. This will be from the controlled outlet and script. Okay. Then I'll right click and add rule to all zones. Okay, that's done. Control A and then delete to just delete everything. Control V is going to paste. I'm going to come up here to my release east, copy it, and then paste that in for my release. And the reason why it's different is because our inflows are different. Therefore, our total inflow will be different. That will affect the release and everything. So I wanted to do two reservoirs to kind of show that difference in what that looks like. All right, so I'll go ahead and click apply, and then we'll run the simulation again with these scripted release rules. I'm just going to pull this over to the side and then run the script. And we have a problem here. Okay, so I misspelled something. Yeah, there needs to be a P here. I know, C. All right. All right, so that's saved, and then I have to make the same change over in the West Reservoir for that scripted release rule. It's probably the same problem. Yep, because I copied it. And then C. All right, apply, compute. Okay, so we did not get an error. That's good. Right click. Let's take a look at the plot. Okay, let me toggle off the base case with no rules. Plot. All right, interesting. So this is okay. What we see here is the guide curve on the top plot. We have the water surface elevation, and it's trying to keep the water surface elevation close to the guide curve. That's all right. It's not great actually, but and then in the bottom we see the flows. So we have the same inflow we did before, and then we have our releases, which are all over the place. Let's go ahead and check out the East Reservoir. Looks East Reservoir looks similar. Here's our water surface elevation, and then here is our releases. That's not exactly what I want, but it worked. I mean, it released water and tried to keep the water close to the guide curve elevation. Let's go ahead and make a couple of little modifications and then run it one more time and then come back and see what we get. All right, so to make modifications, I could just open up the reservoir editor again. Things I could do here is change it so that I'm not actually updating the gates every single step, but maybe once every 2 hours or once every 3 hours. I could play with that parameter, and I did, but I just stuck with this for the what you're seeing in this exercise video for the video. Another parameter to kind of play around with is this multiplier. So it could be either more or less sensitive to this difference. That was something else that we could play around with. So for instance, I could change this to maybe like a 500. We could see what happens there. Again, this is for the west, so I'll keep east the same. One other thing that I think might help is if we limit the release rule so that it doesn't change too much in a single hour. So what I could do is just add another rule up here in the rule tree that says um, limits the change. Or we could also write that same type of script in the code itself. Let's go ahead and just add that rule to the zone tree rule as a separate rule altogether. And we'll prioritize it above the script rule because it's not a specific rule. And then we'll go ahead and run that and then see what happens. So I'm going to go ahead and click apply. Over here in the zone tree rule, I will add a new rule. It will be called max change increase, the controlled outlet. It is a flow rate of change limit. Okay. That is increasing. That's the default here. And then I'll say, how about 500 CFS per hour is the max rate of change. And then apply. And then I'll do one for the decreasing. So I'll right click a new rule. This will be for decrease. That again will be for the controlled outlet, flow rate of change. Okay. Decrease and then 500. Apply. I'm going to right click, add rule to all zones. And then I'm going to say the script rule is the least move to bottom on the rule stack. And I have to do that for all the zones and move to bottom. Okay, so I'm going to click apply there. I have to make the exact same changes to the east reservoir, so hang with me. Add rule to all zones. Okay, apply. And let's go ahead and run that simulation again. So I'm going to right click, compute. All right, close. Something happened. Let's check out the plot. All right, it looks pretty much the same as before. This was the west reservoir. Let's see if the east reservoir looks any better. Nope, looks the same. Okay, well, anyway, I fuddled around with this for hours and got some better results. And it was with modifying a number of those different parameters. I believe the multiplier was the main one. That was just an example of scripted release rules using HEC ResSim, just kind of messing around with some of the parameters we can use to prescribe releases and the different rules and zones in the zone rule tree to help just give you a little bit more experience and exposure using scripted release rules in HEC ResSim.